Alright, so today we're going to look at back titrations. Back titrations are really cool. You all understand that by now that a typical acid or a base is really easy to do a titration against. But if you've got something that you wouldn't normally think of as an acid or a base, but it will react with an acid or a base, this is where we use a back titration. So, what actually is it? It's where we work out the moles of an analyte. Again, something we don't typically think of as an acid or a base, something that's not overly soluble, whatever, and we work it out by reaction with an excess known reagent. The remainder, so how much we have left over, with that will then be titrated. So once that is titrated, we can work out how much was used, and then we can work out how much we had to start off with of the analyte. So there are three chemicals. There is the analyte, there is the reagent, the known reagent, and then there's the titrant, which we work against. Now you'll know the reagent and the titrant, the concentrations. So basically, we can have one that will act as an acid, then a base, then an acid, or base, acid, base, and that's the way we go. So we react our unknown with our excess reagent. Okay, we use that reaction. An example of that is calcium carbonate as a solid. If we react that with hydrochloric acid, that'll give us carbon dioxide, calcium chloride, and water. But because we've got excess hydrochloric acid, there is still a small amount of, or maybe a large amount depending on what we've got, of HCl over here, and you wouldn't write that in your equation, but you will then work out how much is left over, and that will allow you to work out how much of this, so how much was used, so how much is left over, then you'll work out how much was used, and you'll use that to work out how much of this there was in the first place. So the steps, pretty simple. You write the equation out, and you work out the moles of reagent B that were added. Okay, so again, it's still C equals N over V and equals CV. So if you're using hydrochloric acid and you know that it's 0.11 moles, you would be 0.11 moles, and you know that you added 25 milliliters, so it's times 0.025. Okay, you then will do a titration of, when the reaction is finished, you'll do a titration to work out the moles of B left. So you're working out what here is left over. Okay, so it's B left plus titrant standard. Now, so we're using two standards now. This is a known concentration, so that's been standardized, and we're putting it against a standard here. Okay, so it's the same as all our other titration calculations by that point. You can work out what is left in here by working out the moles of this that was used, okay, and then use your molar ratios to work out how much was left. And then we do a little subtraction. So we work out the moles of B consumed. So moles of B consumed equals the moles of B added, so the total amount you put in there in the first place, minus the moles of B left. Okay, so this is a really practical example of, a really useful example of a titration that an analytical chemist would use. And from that, you can use the moles to work out the moles of A. You can work that out from the molar ratio in the very first equation that you wrote out. And that's it. That's it. You're done. That's how hard it is. So let's have a look at the steps in a little bit here. First, we've got analyte A in our Erlenmeyer / conical flask. You pipette in a known amount of B. Remember, this is known really well, like the concentration. And then we will titrate. So this will pour in here. It'll react. It'll bubble off it goes, and you've just got a solution down here. You then titrate it with the titrant, which is also a known standard. So this is where we're at. So this is a known standard, and this is a known standard. And you do this to work out how much B we have left over. And then there's one final step, as with all titrations, maths. And it's really simple stuff. It's all C equals N over V or N equals CV. That's it. That's where we're at. So back titrations, they're super duper simple. If you're doing this from scratch, it's going to take a long time because you've got to make 2 known standards. Then you can work out your analyte. But we're chemists, so we're pedantic and we're picky, and we love it. Alright, if you have any questions, feel free to ask them in the comments below. We'll get back to you as quick as we can. And yeah, see you next time. Thanks for watching. Bye now.